Hola, soy Antonio José Rodríguez, director de Data e Inteligencia Artificial en Generativa Iberia. En este momento de auge de la inteligencia artificial que estamos viviendo, yo considero de especial interés para cualquier tipo de compañía el conocer cómo sacar el máximo partido de ella. Hay que tener en cuenta que el objetivo no debiera ser la mera implantación de soluciones tecnológicas de inteligencia artificial, sino la mejora de los procesos usando la inteligencia artificial como medio. Sin más, os dejo con mi compañero Jacob Clement, de Convali, una de las empresas del grupo Eraneos, que os va a exponer dos casos de uso con los que obtuvimos resultados muy significativos en nuestros clientes. I hope you find this video interesting and see you later.
Hi and welcome to my presentation about our generative AI use cases. Today I will show you two interesting use cases which are actually in production and not in the proof of concept state. But first of all, who am I? I'm Jacob and I work for Convalid Analytics, which is a subsidiary of the Eraneos. We are mainly focused on generative AI solutions, and we've been around since January 2022, where we developed the first German use case for GPT. Actually, this particular use case went live December 2022 for the Deutsche Telekom and now helps the Deutsche Telekom to optimize their customer experience and analyzing 90 million customer interactions per year. We also presented this particular use case at the Microsoft Summit in Munich, and we were the first productive use case of GPT in Germany. Since then, we are scaling GenAI use cases for telecommunication, insurance and banking industries and have been awarded Best Consultants 2024 for AI in Germany. Before we start deep diving in our use cases, I want to give a brief introduction into the topic of generative AI from a more data science perspective. So, generative AI is actually just one subset of the ongoing revolution in data science. And if you just try to do some name dropping, we do see big database statistics being around since a long time, and then automating those statistics, we call it artificial intelligence. And by using more and more computers, we started doing machine learning. And if you actually use a lot of data, this is called deep learning. But in the area of deep learning, we have two different categories, which is on one hand predictive AI and generative AI. And generative AI is not the solution for every application. Also, predictive AI is really interesting. And to show you some differences between those two methods, let me give you an example. For predictive AI, it's all about forecasting and classifying. So let's say we have a structured data set of doc images. And if we train the predictive AI model, we can achieve that the model can recognize docs, right? So if you give it an image, it can say there's a doc on the image or there's no doc. For generative AI, that's a bit different. Here, the model can handle unlabeled data and define its own structures. This means you just give it a lot of pictures without labeling them. And then the model learns itself from those images and can generate based on those images. So it will generate you a doc instead of saying that there's a doc on the image, right? In a more business-related context, this would be, for example, if you want to analyze the satisfaction of different customer groups. Using predictive AI, you could pinpoint directly those customers who, for example, are unsatisfied, right? So the output is binary, satisfied or unsatisfied. If you use a generative AI model, that's a bit different. Here, it's not about classifying or forecasting, it's about imagining a customer who is unsatisfied or satisfied. So again, the generative AI model generates content and the predictive AI classifies and forecasts. But why is generative AI so revolutionary? If you talk about large language models, you actually see that they have been around since a long time. Also in 2018, GPT was released and the underlying architecture for those models are all the same. But something changed, and that's the pure size. And if you look at this animation, you will see the model size, especially the parameters, are way bigger. So for GPT-3, for instance, we are talking about 175 billion parameters, which is insanely big. But that's not the only reason why this is so successful. First of all, the invention of the transformer architecture, which was done by Google way before GPT-3 was released. But it enables us to train such huge models. And then the exponential growth in model size and computing power. So we have built network centers which are able to train such huge models. Also, the access to those models are really easy. So if we are using a cloud, everyone can just simply make calls to such huge models. And then that's important for us in the EU. We also have compliance solutions to use those models. And if you look into companies' data, only 20% of the data is actually structured. So from the ERP system, CRM, or for example, logs. But as we saw, generative AI is especially useful if you want to analyze unstructured data. And that's actually roughly 80% of all the company's data. This could be emails, could be voice, presentation slides, social media, wiki, docs, whatsoever. So here, the generative AI models come really into handy. And that's the last slide for the introduction. What's also interesting, if you look at big tech, which is always a step ahead, you will see that they are filing a lot of patents regarding generative AI, which is also a sign for a sustainable technology which will stay around for a longer time. Okay, enough for the introduction. Let's dive into some use cases. First of all, we have defined or we selected many use cases across different industries and selected which are interesting for generative AI and which are more suitable for predictive AI. Now we just focus on the generative AI ones. And I've brought two really interesting use cases. But before we start into those, it's important that you could build up a set of capabilities to speed up the process of tackling those use cases. In terms of generative AI, this could be a map of capabilities which we have developed. For example, generative AI can summarize huge amounts of text. We can do advanced sentiment analysis, interpret moods and tones. We can do clustering. We can do info extraction, but obviously also Q&A engines, for example, chats. Text generation is a huge thing for generative AI, but also different areas like coding can benefit from generative AI. Last but not least, if you do a little bit of coding around those models, you can also do things like quantification. If you take those capabilities, you can build great things. For example, our first use case, which is about information extraction. Before we jump into the live demo, I just want to tell you some things about the situation of the customer, which we have built the solution for. So in that particular case, we want to look how can we use large language models to support central tasks in contract creation and migration. So the problem here was, for example, to reduce growing backlogs. The problem here was that the insurance company, which we have developed a solution for, needs to migrate a huge amount of contracts, life insurance contracts, roughly 40,000, to a newer system. The old system is not really structured. We just have the contracts lying around, and we need to bring them into a structured database form for the new tool. Also, the documents are really chaos. So they are not nicely scanned PDFs. It can also be handwriting on napkins, or it can be emails of updating information. It can be everything. So it's not that easy. An employee from the insurance company takes on average 2 hours to migrate one contract to the destination solution. But sometimes it also takes up to 8 hours. This is because the migration is really complex. It's not about only extracting information such as name, date of birth to the new system, but also really focusing on the specialties from the contracts. You need to summarize, for example, the medical conditions for some customers. It involves numerous verification within the application. We want to extract data. We want to summarize data. We also want to have some custom logic to apply before we bring the data into the new system. And that's especially interesting, all the peculiarities. So, for example, daughter Anna still is in studies, or we have some other medical conditions. And we need to summarize them and bring them into the new system. What's also really interesting is that we need to ensure that the system works, so that we have a good confidence that all the extracted material is correct. And you can think about percentages saying how confident the system is. We will see in a second that this is not so easy, but still we need to find a way to create transparency on the process to ensure that the new system actually has good data. Because the general rule is shit in, shit out. This means we need to be very careful. Before we jump into the final solution, I want to take you on the journey and show a little bit of our workbench where we did different tests on how our system works. And for that, I need to switch to my laptop. Before I show you the final product we've built, I want to start off by showing you some of our test examples. First of all, it's important that we can extract the information from the documents in a good quality. As I said, some of those are in chaos and are not really well scanned PDFs. In this example, we are looking on how GenAI can actually enhance classical OCR systems. Okay, I will upload a demo receipt from a doctor, and as you can see, it is really hard to read. So it's French, but there were also some Arabic signature around this text is from Tunisia. And now we want to extract the actual text. If I close this one, you will see that a classical OCR system, which is available on every cloud, does a fairly okay job. But if you look in detail, you can see that things like the actual amount is extracted wrongly. So 1,250 and it's actually 250. But we can also use the large language model, especially the vision capabilities. We can not only insert text, but also images. And also try to transcribe the text. And again, you see in a solution, an output which is almost perfect. But the magic comes into place if we combine both methods, which we call OCR+. So we interpolate between the OCR solution and the vision model. And if you do so, you really get a great output. And if I read through, I, the undersigned Dr. Zaruk Haitem, certify having received a sum of 215, which is correct. And then the diagnosis, which is also pretty complicated for an OCR system. And that's really nice because we can, on one hand, use classical OCR systems, but we can also use the vision capabilities and the context which a generative AI model has to really reconstruct what's on the documents. I have a second example which is quite interesting because it's not always just text. Let's say we want to report a crash scene. And in that example, we have a scribble of a car turning right, and then there's a bike, and we have a crash, right? A classic OCR system obviously cannot detect scribbles. It's just trained for text. And if you have a look, you can see the OCR text just extracts or tries to extract the text below. The vision model instead can really understand the sketch. And you can see here the diagram shows intersection with 4 streets labeled as Top Street, Dale Street, High Street, and then also some mistakes, which is also okay. I will show you in a second how we handle those. And then also the handwritten note. And if we combine both solutions through the interpolation step, we really get a great output which we can use in our system. This can get even more complicated. For example, if the use case is that we need to check surgery invoices. I will show you this in a second. A classic scenario for medical insurance company is that if you have a surgery and you will get the invoice, you need to check as a company each line on the invoice. If the codes are correct, if the amount is correct, and the factor, right? But not only for the invoice, you also need to compare it to the report from the doctor to the surgery. And you really need to check for each line in the invoice if actually what I've stated here is also stated in the report. Actually took place during the surgery. And here we can use GenAI on one hand to extract each line of the invoice, but also to compare the report to the invoice. This takes a bit longer because we do the calculation for each line in the invoice. Okay, as we can see here, we have now our AI output on for each line in the invoice. We do have the information extracted and also the check towards the report if the actual thing was actually done during the surgery. And we can check if there are any discrepancies. So as you saw, we cannot only extract information from documents which are in a really bad condition. We can also could also apply logic to improve our system. Let's jump to the final product, to the case I presented. So let me log in. This case is actually in production and up and running. So on the left side, you see collections. Let's say one contract which contains multiple pages and documents is one collection. I have a demo collection here to show you the capabilities. Inside the collection, I have 3 documents. The first one being a long document of a random contract, which is not so important for this demo, but important is that we have 42 pages, which normally we should need to read through. We also have an image and handwriting of a service agreement, and we do have an email saying that the email address stated in the image was not correct, and now it's this email, this address. So what we can do now is define a checklist, pretty easy because we can use natural language. We do not need to fine-tune any model to say which information we want to extract from those from those documents. And the AI system will pre-fill all of the values for us. So we can check through the list and just have to say, okay, this information is correct, maybe that's not correct, and we need to adapt. So we're really leveraging the human in the loop aspect. But how can we ensure that the results are actually correct? On the slide we saw a confidence value, but that's not so easy if you use generative AI models. It's typically not possible. So we need a different kind of solution to do so. And in our example, we built a system which can track down the position on where the system got the information from. So let's say we want to search for the surname, and as we can see, it found it on the service agreement. You can also see that we have multiple sources. We also saw this surname inside of the email. You can see it up top here. And the more sources we get, the more confident the system is for a given value. But what if we have a conflict for an information? Let's say, in the example of the address, we have an original contract which says address in Munich, but then we have an email which says that I've changed my address to Amsterdam. In that case, we are using GenAI and the context of GenAI to just read through the documents and decide what is the most likely value for the address. In that case, it's fairly easy. GenAI will detect, okay, there's a change in address inside of this email address. Amsterdam is what I need to fill here. But again, if I'm as a human, as a supervisor saying, okay, that's not correct, I'm totally able to change this back to Munich. We also can skip through long documents. In that case, I want to search for the max reimbursement amount of bereavement. And here we see it found the correct line on page, I don't know, somewhere in a long document, right? So it really can read carefully through each document and find the correct sentence. Let me just find the position. We reimburse up a total of $1,000 of counseling expenses, and it filled the value correctly. At the end, the human should just use the AI as a co-pilot and speed up the process of the contract migration by a huge factor. This would conclude our first use case, but we also have a second really interesting use case. In that case, we are not talking about an internal process optimization, but rather something which is customer facing. So we need to be extra careful. So the idea here is to build a voice and chatbot which really feels natural. If you remember all the current chat and voice bot solutions, most of them are really do not feel good, right? It's not natural. That's because a human needs to predefine each possible conversation. And yeah, there are many possibilities if you talk about language, and it's not possible to predefine each conversation. So we really thought we could rethink the whole system. And before I talk you to the detail, I want to give you the chance to listen to an example.
Welcome to our bank's customer service. How can I assist you today?
Hello, this is Mrs. Berner, and I'm afraid that I have a problem. I've lost my card in the city. What should I do now?
Hello, Mrs. Berner. I understand, that must be frustrating, but I'm here to help. First, we should block your card. I see that you have 2 cards with us. Have you lost both?
Thank you so much. Yes, unfortunately both cards were in my wallet. I urgently need those cards.
I understand you need the cards urgently. Let's block them first, and then I can assist you with replacing them. For authentication, could you please provide your first name and date of birth, Mrs. Berner?
My name is Lisa Berner, and I was born on July 28th, the year the Netherlands first won the European Championship. What a coincidence. Oh, let me correct that. It was July 26th.
Thank you for the information. I assume then that you were born on July 26, 1988. I've successfully authenticated you. Mrs. Berner, I'm now blocking your cards. You mentioned that you urgently need the cards. Shall I send you replacement cards by express delivery?
Yes, thank you. That would be great.
All right, your cards are now blocked, and the replacement cards are on their way and should reach you within the next 2 to 3 days. Is there anything else I can help you with?
That's wonderful. No more questions from my side. Bye.
Then I wish you a wonderful day, Mrs. Berner. Goodbye.
As you can hear, the conversation sounds really natural. The GPT really grabs the context of the conversation. For example, I lost my card in the city, and the system can say, oh, that's bad news that you lost your card in the city, right? So it's really a human-like conversation. It can also simultaneously recognize different requests, save them, and come back later. And it can do a lot more than a simple sentiment analysis. It can detect if the customer gets frustrated and maybe redirect to the customer center directly. And what is the system behind the voice bot? So there's an approach called mixture of expert, which have been around since 1991 and was developed by the MIT, Massachusetts Institute of Technology. And since then it was rapidly scaling in the field of computer vision, but now it's also used in the area of large language models. And I'm not talking about the technical implementation or the training of large language models. I'm talking about the general approach. And if you translate this into our next gen bot case, you can really build something like that. So it's too complex to build such a system with only one model, right? There are many different cases requests. For example, we want to implement an address change, an intent for blocking your cards. So you cannot build it with one model. We also have a complex business side. We have complex APIs which we need to call so that the actual voice bot can do actions and actually block the card, for example. So we are not relying on one specific model, but a range of many models. If the user now sends the requests to our system, we have one coordinative model which decides which of his other expert models need to handle the request. So let's say we have one export model for the address change, one export model for blocking your cards, and then you could have any amount of more export models. There are no limits. But the system decides itself which model it wants to use to handle your request. So using such a system, you can really scale up GenAI applications, combine it to complicated business backends, but also have the natural flow of generative AI chat capabilities. I also have 4 facts you might not know about GenAI yet and might be interesting. First of all, multimodal models will be huge in 2024. And that's not only models for language, but also models for vision, models for hearing. So one model can not only read text, but can also have different options to interact with the humans. As we saw in the document case, we also use the vision capabilities to understand the scribbles of the documents. And on our case from the next Gembot, we used hearing to understand the tone of voice of the customers. We also saw that we could use large language models working autonomously together. So we just don't have one large language model, but many. And they solve complex tasks by themselves, by communicating to each other. And then, that's also interesting, the big market player tried to make models smaller, so that it's not only runnable in the cloud, but also maybe sometime can run on your local iPhone. This makes those models more accessible and more specialized to different scenarios. And what will be interesting, and is the most of the focus for us, is to integrate the company's data into the GenAI. And you really don't have to retrain the models. You can just use approaches, for example, like RAG, which stands for Retrieval Augmented Generation, to combine the company data using a retrieval system, for example, a search, Elasticsearch inside of the company, searching for the documents, and then augment this to our GenAI models, enrich the models. And then you can do a generation from large language model using the company-specific data. So you have the base prompt, attach company data, and then you get a highly individual response. Okay, this will conclude my presentation. Thank you so much for watching and have a great day.
Hola de nuevo. Gracias por vuestra atención. Espero que el vídeo os haya resultado realmente interesante. Y si necesitáis más información, no dudéis en contactarnos. Gracias.